Hi, welcome back to freesciencelessons.co.uk. By the end of this video, you should be able to describe how the particles are arranged in solids, liquids and gases, and how this arrangement changes during melting, freezing, boiling and condensing. You should then be able to explain why some substances have got higher melting and boiling points than others. And finally, if you're a higher tier student, you should be able to describe the limitations of this simple particle model. Now, there are three common states of matter, and I'm showing you them here. We've got solids, liquids and gases. As you can see, the particles are arranged differently in these three states of matter, and you need to be able to describe how they're arranged. We're going to start by looking at the features of solids and then explain these features using particle theory. Firstly, solids are extremely hard to compress, in other words squeeze. That's because the particles in a solid are packed together in a regular pattern with almost no spaces between the particles. Secondly, solids have a fixed shape and they cannot flow from place to place. That's because in a solid, the particles can vibrate, but they cannot move from place to place. Okay, let's look now at liquids. Just like solids, liquids are extremely hard to compress. And again, that's because the particles are close together, with not many spaces between them. Unlike solids, liquids take the shape of their container and they flow from place to place. That's because the particles in a liquid can move. Okay, we're going to look now at gases. Firstly, gases are extremely easy to compress. That's because the particles in gases are widely spaced. Secondly, gases spread out and fill the space of their container, and that's because the particles in a gas move quickly and randomly. Okay, now we can change the state of a substance by putting in or taking out energy, so we're going to look at that now. I'm showing you here a solid changing state to a liquid. This is called melting, and this takes place at the melting point. Now, as you can see, the particles in a liquid are moving around, so they've got more kinetic energy than the particles in a solid. This means that we've got to put energy in to convert a solid into a liquid. This energy is needed to break the forces of attraction between the particles in a solid. Once these forces are broken, the particles can now move around. In other words, we've changed the solid into a liquid. Now, there's one really important fact that you need to understand. The stronger the forces of attraction between the particles, the more energy we've got to put in to break them, and the higher the melting point. I'm showing you here a wax candle. Now, candle wax is a solid with a relatively low melting point, and that's because the forces of attraction between the particles are relatively weak, so they're fairly easy to break. This shows sodium chloride. In this case, the forces of attraction between the particles are very strong, so sodium chloride has a very high melting point. Going back to our diagram, if we convert a liquid back to a solid, then this is called freezing. This takes place at the same temperature as melting, in other words, the melting point. Okay, now we can also convert a liquid into a gas. This is called boiling, and this takes place at the boiling point. Just like before, if there are strong forces of attraction between the particles, then the boiling point will be high. That's because it takes a lot of energy to break those forces and boil a liquid. We can also convert a gas back to a liquid. This is called condensing. Condensing takes place at the same temperature as boiling, in other words, the boiling point. Okay, now if you're a higher tier student, then you need to be able to describe the limitations of the simple particle model of solids, liquids and gases. So we're going to finish now by looking at that. Firstly, the simple particle model assumes that all particles are solid spheres. Now, this is simply not the case. Particles have got lots of different shapes and they're not solid. Secondly, in the simple particle model shown here, it's assumed that there are no forces between the particles. Now, as we've seen, this is not correct. In fact, the forces between the particles have a major impact on the melting and boiling points of a substance. Remember, you'll find plenty of questions on states of matter in my revision workbook, and you can get that by clicking on the link above.